What's up everybody, welcome to MyPixel. As always, it's awesome to have you here. If you're new to the channel, then welcome. Today we're going to create a screen shake effect in our game so that we can give things that extra impact where we need it. If you don't already know what screen shake is, just think of that effect that you see in movies where the camera shakes around all over the place when there's something like a big explosion or maybe Godzilla takes a step. Alright, let's do it. First, let's go ahead and decide when we want to use our screen shake effect. Now last episode, we went ahead and modified our enemies and gave them different speeds and HP. Why don't we do something similar and make an enemy that's just completely bigger, right? He's larger than the rest of them. The bigger they are, the harder they fall, is a saying that you might have heard, right? So let's go ahead and make the screen shake when we destroy a large enemy, right? Big enemy hits the ground, shakes the ground, perfect place to put a screen shake. So now that we've decided what we're going to do, let's go ahead and make one of those enemies bigger. Okay, so let's jump into our enemy and our enemy script. Here we go. Okay, so if you follow along last episode and you remember the export variables that we made, we're going to go ahead and create a new one today. So let's do it. So we're going to do the export. Let's see if I can get this here. Export vector2. We're going to call the variable size, and we're going to give it an initial value of vector2, 1, 1. Okay, now that we have this size variable, we need to make use of it someplace. So in the ready function, which is going to get called when the instance gets initialized for the enemy and whatnot. Basically, this is what happens first. So the first thing we want to do is we want to set him to the size that we gave him. So how we do that is we use the scale. Scale is built in here. If you see in the enemy, if you look down in the inspector node 2D, the transform, there is a scale. That's what we're modifying right here with the scale. So scale equals size. Right, so scale takes a vector2 and we feed it our size, our new size variable, which is a vector2 also. Pretty easy. Okay, and now we might be getting a little bit ahead of ourselves, but just so that we don't have to come back and touch anything else in this enemy script, we're going to go ahead and call the screen shake function. Yes, I know we haven't created it yet, but we're just going to go ahead and call it. So we want to call the screen shake function when the enemy is dead. So we're going to go into our dead function here. Under if HP is less than or equal to 0, this is when he is truly dead. Other than that, he just gets his HP reduced. But when his HP is 0 and he dies, falls down, we're going to need to call our screen shake. So now we only want this screen shake to happen if this was a large enemy, right? So we're going to say if scale is greater than vector2, 1, 1. So if any part of this vector2 is greater than 1 on the x or 1 on the y-axis, or maybe not x or y-axis, but like this is an x value and a y value. If any of those is greater, like you'll see later on, we're going to set the size to 2, 2. So that's going to be greater than 1, 1. So that would make him a large enemy. So if it's greater than 1, 1, which means it's a large enemy, then we're going to do get parent, which is our stage 1 scene. We're going to do a get node. The node's name is screen shake. Again, we haven't created this yet, but so what we're going to do is eventually we're going to, in the parent, which is our stage 1 scene that's got the player and the tile map and everything, inside of there we're going to create a screen shake node that contains a screen shake function that will take these arguments. The 1 is eventually going to stand for 1 second, the 10 is going to stand for 10 pixels that we want the screen to move in each direction, and the 100 here is going to be part of a priority system that I will get into explaining. So Now that we've had that added, right, we've got this all in here, then we need to get into our stage 1 scene, and we need to go ahead and create that screen shake node and function that we're calling here. So we jump back into our stage 1 scene, and okay. Actually, it's a little bit hard to see that we're in our stage 1 scene because it's still showing the enemy script. So let's just go ahead and pull up the little image here, then we can tell we're obviously in our stage 1 scene. Now inside over here, we're going to create a new node. So make sure that stage 1 is the parent. Right? Just select stage 1, and then when we add 1, it's going to be a child of stage 1. We're going to create this new node here. We're just going to use a node 2D. This is just going to be more like a container or a placeholder. There's nothing special about this node 2D. And we're going to rename this to screen shake. Okay, and as a child of this screen shake node, we're going to add another node. And this is the first time we've used this node in the series. We're going to use a tween node. So add that here. So this is what you should have. You should have the screen shake, and as a child of that, then you should have the tween. Okay, so if you select the screen shake then, and then we're going to add a script to the screen shake node. So click your add script, go ahead and create the new script. Okay, here we go. Now let's get to the code part. So let's delete all this stuff that we don't need. We'll hold on to this ready function for now. Okay. Now on the top here, we're going to go ahead and create a variable. So we're going to say var, and we're going to call this variable current shake priority. And we're going to set it equal to 0. So this current shake priority variable is part of a priority system so that lower priority screen shakes don't cancel out or override higher priority ones. So maybe if you think of an example, if you have Godzilla walking through a city and shaking up the whole scene, you wouldn't want to override that big shake with the little shake that maybe a mouse sneeze might cause, right? Sorry for the lame analogy, but I think you get the point. So that's what the shake priority system is there for. Next, what we're going to do is we're going to create a couple of our own functions. So let's start off with this one. We're going to say func move camera, and we're going to feed that a one value, which is eventually going to be a vector or a vector 2. So func move camera with the argument named vector. We're going to say get parent, which in our case, as you can see, screen shake's parent is stage 1 scene. So from the parent, we're going to go ahead and move my thing there. Get node. We're going to get the node player, which you can see in here. The player is the one that's got the camera. That's why we're accessing the player. So get parent, get node player. What do we have next? We have get node camera 2D dot offset. So what that is if we jump back into our player, I'll find it here. So we have our player, we have our camera 2D that we called out, and camera 2D someplace down here has, it's not that offset. It's not that offset. Where is that thing anyway? Visibility, drag margin, offset. Oh, sorry. It's this offset. This is the property. If you can see here, where it says property offset, so offset is the property name. So that's what we're modifying when we say the dot offset. So let's get back into here, get back into our screen shake. So get parent, get node player, get the player's camera 2D, and we're going to modify the offset That's what this function is doing. So we're going to set the offset equal to vector2 rand range negative vector.x vector.x rand range negative vector.y vector.y. Okay, now that was a long line of code and a mouthful, but we'll go over it right here. So rand range, all rand range, excuse me if I can get my highlighting and everything to stay. Why is this not expected? Oh, sorry, missed a close parentheses there. Okay, that error should go away. Okay, so we already talked about the offset. Now we're going to vector2 rand range. So rand range, what this does is it takes two arguments, right? This argument 1 and argument 2. And what rand range will do is it will pick an integer between these two numbers. So between a negative vector x and a positive vector x. Now this vector x is the x component of the vector 2 that we will eventually feed into this function. So let's say we fed, let's say we said move camera vector 2, vector 2 of 1, 1, right? So 1 on the x and 1 on the y. So then what this rand range would say, highlighting keeps jumping all over the place, sorry. What the rand range would say is I want to pick a number between -1, right, our x value, and +1, our other x value. So similarly, we're going to have a random range and we're going to say we're going to pick between a negative value of our y value, which in my example just now was 1, but we're going to set it to something different. And then, so -1 and +1, right? So all of this is going to make up the vector 2 that we need to set the offset, because the offset accepts the vector 2. All right? Oh yeah, and all the offset is going to do is it's just going to take the camera and it's going to move it by that certain vector, right? So if you say 1, 1, then that's going to move it 1 pixel to the right and then 1 pixel down. If you say -1, 1, it's going to move it 1 pixel to the left and then 1 pixel up. So that's all that setting this offset is doing. Now that we got that one done, let's go ahead and add our next function. So this one, we're going to say function, and we're going to call this screen shake appropriately, right? That's what we're trying to do. We're trying to shake the screen. So, and our screen shake function is going to take 3 arguments, right? We need 3 values to make this screen shake work. We're going to want a shake length. So this is just the amount of time that the screen is going to shake for. We're going to want a shake power. This is just going to be how much the screen shakes, right? How violent the shake is. And then we're going to want shake priority, which is part of that priority system that we talked about just a little bit ago. Okay, so that's the name of our function and our arguments. And then we're going to say if shake priority is greater than current shake priority. Okay, so if the shake priority, that's this, that we feed into this function, is larger than the priority, let's say the screen is still shaking, right? It's a 10-second shake, it's still shaking, and we want to shake it again. If the new shake has a higher priority than the current one happening, then we're going to want to go ahead and shake the screen. if it's got a lower priority, it's not going to do anything, and it's just going to keep on shaking with the previous shake. So if shake priority is greater than the current shake priority, then the first thing we're going to want to do is we're going to reset the shake priority, the current shake priority, right? We have a new shake. We decided we want to run a new shake, so we want the current shake priority to reflect the new shake's priority. Okay, so, current shake priority equals shake priority. All right, so lame joke, now we've got our priorities straight. Now let's go ahead and write some code that's going to make use of our tween node. So this is what we're going to do. I'm just going to type this all out. It's pretty long, and then I'll explain it afterwards. So don't worry if it just blows right by here. So tween dot interpolate method self move camera vector2 shake power vector2 0 shake length tween transsign tween ease out 0. Okay, now, yeah, like I said, that's a very long line, and I'm going to try my best to explain it. So here we go. So with our tween node, the tween node has a function or a method. It's called interpolate method. So we're using that. Actually, before we go into that, let's go ahead and talk for a little bit about what a tween node actually does. A tween node will calculate in-betweens between two different given values. So for example, if I feed the tween node a value of 1 and 10, the tween node is able to automatically give us the numbers of 2, 3, 4, 5, 6, 7, 8, and 9. Now you may have heard of tweens in relation to animation. For example, an animation program might be able to produce in-between drawings between other drawings. The program does it automatically to create smooth animation. If you have a ball that's falling to the floor, then all you would have to do is draw the ball where the ball starts in the air and then draw where it lands on the floor. And the animation program would, quote unquote, tween the rest of that for you. So hopefully that gives you a little bit of an idea what tweening is if you've never heard of it before. But yeah. So here then what we're doing is we're using the interpolate method. We're saying that we should look inside the screen shake script with self, right? Self says to look in the current script. So look inside the screen shake script for a function or method called move camera, which you see we just created earlier here, right? So inside of itself, find the function move camera. We have a starting value, which is a vector2 that takes these two variables, shake power and shake power. This is what we feed into it as an argument. So if we say, if we go back into our enemy and our script, we said our three values we're passing in are 1, 10, and 100. So we go back in here, right? Shake length would be 1, shake power would be 10, shake priority would be 100. So a vector2 of shake power and shake power is then a vector2 of 10 and 10. So that's the starting value. The ending value or final value we set to vector2 0, 0. So it's going to start with a large shake and it's going to finish with just a teeny little shake until there's 0 shake left. The shake length, like we said, was 1. This is just the number of seconds that this tween will take to finish. So basically the screen is going to shake for 1 second. We have a transition. This is how the numbers get calculated for the in-betweens, and it's just using a sine function. And then we have the easing. So we're using an ease out function. And then we have a delay, which we set to 0, because as soon as we tell this tween to start, we want it to immediately run, right? We don't want to wait at all. So that's why that's 0. So then to summarize, right? So in summary, because that was a lot of stuff to look at, this tween node will call the function move camera every frame for a duration of 1 second. The values that it gives as arguments to the move camera function will start at this vector2 shake power. That's the starting value, and it will eventually end at the vector2 of 0 and 0. With the ease out function, this is going to make the values rapidly approach, right? They're going to start from 10. It's going to rapidly approach 0 in the beginning, and then it's going to very slowly approach 0 at the end. This is because of the ease out function. Now, some of you may be unfamiliar with easing techniques like ease in or ease out, in which case you might just want to give it a quick Google search, read a little bit more about it. It's a pretty simple concept, and I think after you read, a few paragraphs about it, you'll be totally good to go, and you'll understand it. Again, like I said, very easy, but there's somebody else on the internet that's going to be able to explain it better than me, so I'll leave it to them. But in any case, if you're just following along, yeah, we're using ease out, right? So basically this is going to create a large shake, right? You'll see it move very fast at the beginning, and then it's going to trail off at the end very slowly, right? Okay. And now that we have all that down in there, we need to tell our tween node to actually do something. We need to tell it to start, sort of like how you need to tell an animation to start. So we're just going to say tween dot start. And we tell the tween to start and do its thing. Now we're almost done here, but we still need to reset our shake priority variable after the screen shake is done. If we don't do this, then any shake smaller than the last one that ran won't be able to run, even if that previous shake has been finished, right? So if I call the shake with a priority of 100 and it's running, right, we set the current shake priority to 100, and we never set it back to 0. So maybe we want to run something with a priority of 10. Even though that shouldn't run while the big shake is running, maybe the big shake's done, right? So we need to create this low value so that all the new shakes can run. So how are we going to do that? Well, for that, we're going to want to know when our tween, right, this thing that does its deal for a duration of 1 second, we're going to want to know when it's done. Now, an easy way to do that is to use the tween's built-in signal. Gotta love it. There's certain things that Godot's got in here. Signals are really powerful. They're really easy to use, and they're really straightforward once you use them a couple times. So, in any case, with that being said, we're going to go into our tween node, and we're going to use the tween completed signal. So go ahead and double-click that, and we're going to connect that. Right? Make sure you don't connect it to your stage 1 scene or anything like that. We want it to be connected to our screen shake node. We want a new function to be created, and we will connect. Okay, now we have this. We're not going to need this pass because obviously we're going to write something else in there. And this is going to be really easy. So when the tween completes, all we want to do is we want to reset current shake priority to 0. So priority. Okay, so current shake priority equals 0. And then that's it for that. So with this, it's going to be possible to, again, call any priority screen shake after the current one is done. Okay, we're almost there. I promise. We're really, really close. So let's go ahead and give that a save. So now with that, we need to go ahead and adjust some of the enemy sizes. If you can remember, we are only going to run this screen shake if our enemy size is bigger than the default scale, right, of 1, 1. So let's go into our stage 1 scene. Let's make it so we can see some of our enemies. And I'm going to attempt to make this fun here. Let's take this guy here, sort of towards the end, right, after you've beaten up a bunch of the easier, smaller guys out there. We're going to set his size to double. Set his size to 2, 2. So that's going to make him twice as big as he is now. And let's also set this guy's size to 2, 2, just so that we can see our screen shake effect happening more than once. Alright, let's hit enter on these values to make sure they stick. Okay, so 2, 2, enemy 5, or enemy 6, and then enemy 5 I've got over here is also gonna be a bigger one. You can't see it in here, it doesn't adjust, but when you run the game, that's where you're gonna see your change. Okay, and with that, let's go ahead and run our game and see what we get. Okay, give this a shot. Sorry, I'm gonna waste a little bit of time knocking down some of these other guys in here. Hopefully I don't die on the way there, and then this will take even longer, be more painful. Okay, so we got our big guy, right? Pretty scary. Let's see what happens when we knock him out. Right, so I think everybody saw that. You saw the screen shake. Now it's stopped, right? Now let's go find the other guy. Get another little bit of that nice screen shake. Right? You think you're so big, man? Alright, take this. Alright. See, so we got that really nice screen shake. And we can run our game, and you know, when to use screen shake is really gonna be an artistic choice. You don't want to use it too much, in my opinion, or you know, it just sort of starts to get dull, and you know, it's like it's not special anymore, right? If you overuse it, it's not special. So you know, depending on what you like, what you think other people like, right? You pick your places to put your screen shake. Maybe just like we're doing today, you know, pick a couple of big guys. You could make the screen shake when they walk, or you know, maybe he falls down from the sky like a big boss falls down someplace over here, and you know, shakes up the whole screen and scares the player half to death or something like that. But you know, play around with it. But as you can see, it's not all that hard to implement. There was a lot of stuff that we had to go through, but I think it's a really cool effect. And I think a lot of you will really find value and enjoy putting it into your game. So play around, have fun. Today we created a cool screen shake effect that will give your game that extra bit of polish that you might have been missing. We also learned a little about the tween node that can do a lot of the heavy lifting for us, so that we don't have to manually do things like input formulas for things like ease in and ease out. So that's going to do it for today, ladies and gentlemen. I'd like to thank you all for watching, and I really hope you found this helpful. If you liked today's video, please give it a like and hit that subscribe button if you haven't already. As always, the sprites, source code, and everything else that I've used in this tutorial today is available on my Patreon page. So if you want to check that out and also support the channel, the link is in the description. And with that, we're going to call it a day. So thank you again to everybody for watching, and I'll see you in the next one real soon. Take it easy.